is being drained from a container which has the shape of an inverted right circular cone. The container has a radius of 2 inches at the top and a height of 5 inches. At the instant when the water in the container is 2 inches deep, the surface level of the falling rate is 1.9 inches per second. Find the rate at which water is being drained from the container. Since water is being drained from a container which has the shape of an inverted right circular cone, we can relate this with the formula of volume. We know that the container has a height of 5 inches and a radius at the top of 2 inches. But we want to know the radius of the water when it's at 2 inches. And to do that, we use a simple cross product of similar right triangles. We isolate for radius passing the edge to the other side. So now we only have to replace the values into the formula. Volume is equal to pi over 3 times the radius 2 over 5 h squared times h. That gives us volume equal pi over 3 4 over 25 h squared times h. Now we multiply both parentheses and that gives us volume equal pi over 3 4 over 25 h cubed. So that gives us volume equal to 4 pi over 75 h to the cube. Now that we have the height isolate and we want to find the rate of water drained, we differentiate with respect to time. That would be equal 4 pi over 75 h cubed. And now we use the chain rule. That will be the derivative of height times 4 pi over 75 height squared. And now we can simplify 3 and 75, and that will give us 4 pi over 25 h squared. And now we multiply times the derivative of height. That will be dh over dt. So now we only need to replace the variables with the givens. dv over dt equal 4 pi over 25 times 2 squared times 1.9. We multiply and that will give us 4 pi over 25 times 7.6. So now we multiply everything and it will give us 1.216 pi inches cubed per second. So the final answer we rounded and that will give us 1.25 inches cubed per second.